Welcome to Let's Make a Game Platformer, episode 8. In last episode we changed how the keyboard controls work. We introduced the physics system to allow to apply some forces on the every moving objects in our scene, in our game, and also added collision detection so that the player character, after adding the gravity, no longer falls through the platforms and also cannot move onto a block that is onto a platform, the inside of the platform actually. However, there is a small bug introduced. Maybe I'll be able to demonstrate it, which, well, it's not really a bug in the code that we added. It's something that is a consequence of a couple of things, how the computer works. Our players sometimes can fall through the platform. This happens when, for example, we are not receiving the updates often enough, and when the object calculates its new position after a frame, it finds itself under. So, for example, the object was here, our character was here, and after seeing that 2 seconds has passed between rendering this frame and next one, it finds itself here and says, "Okay, I'm not colliding anywhere, so I'm fine to fall through it." So to fix this, we have to make sure that the maximum amount, there's a maximum amount of time that we can pass between 2 frames. And to do it, we'll just do it here. We'll specify that time that has passed is limited to 30 milliseconds. That means 30 milliseconds is a good point because this means it's like 33 FPS. So this is something that we should be aiming that our game should be not slower than 33 FPS. Then this will not have any impact on the game. However, if game stutters either on your phone or machine for whatever reason, sometimes it just pauses for a short period of time because some other application, for example, is running on your computer. You don't want your character suddenly to fall through the platform. So this is how we make sure that we don't do this. And last update time should not be time passed. It should be current time. Current time. Last time updated is current time. Okay, and this is the time that has passed. Correct? Yes. So it's a minimum of what we calculate based on our frame. How often this method is called, but at maximum 30 milliseconds should be happening. So this is our fix for the problem. It's a very elegant fix, and I think this is great for many other reasons, like animation. You don't want to be skipping frames. You want to be like smooth. So now when maybe you've seen it when I was moving the window from one window to another. From one window to another, it's skipped. It waited for it to be moved. So while I was moving it, the character basically stopped mid-air because the game was not receiving updates to it. Okay, so this is fixed now. So next thing I want to work on in this episode is, well, we have 2 platforms. However, we can't move from one to the other because we don't have ability to jump. So let's do that. Let's add that. So we have this player control component. In here we'll add a new value. It's going to be jump velocity. And in the player we specified value. Let's go for, well, it has to be faster than running, of course. Jump velocity, let's go for 7. 7, let's go for 7. So slightly faster than moving velocity. And in the keyboard system, we don't need this one already. We'll have here, after we check this, we'll do if is any pressed, and introduce here jump keys. constant. At the moment we'll just do a space, so just one key only, but it's gonna work for a number of ones. Is any pressed jump keys. Then we want to specify that set base velocity y is player controller get jump velocity, and otherwise it's not pressed. We want to reset it to 0, so the same way we had it here, that if you're not moving left or right, you're not moving you're resetting the velocity in y direction. Same here. Actually, no, we don't want this. We don't want to reset this. Okay, so let's run now and let's see if our character can jump now. Let's hope it works. Fingers crossed. Yeah, you can jump. Let's jump from one to the other. Okay, and so this is something I don't like in games when you can move mid-air. So we will quickly work on eliminating this possibility. So first of all, you shouldn't be doing triple jumps. This is cool. We can maybe add it later, but you can infinitely jump now. And this is something I don't want. So we have to. So we can eliminate both of the problems with one solution. Both moving in mid-air with arrow keys and jump, double, triple, infinite jumping. We can do it both at the same time. So the only time the keyboard system, the keyboard controls should be working is when you're on the ground. So now we're on the ground. Now they will no longer be working. The same for jumping. You should only be able to jump when you are standing on something. So in the kinetic object component, we'll add a new field of Boolean value is grounded, which means is standing on the ground. We'll add a setted for it. And in the keyboard system, we'll be doing all the processing if and only if the character is grounded. So we have to, first of all, get the kinetic object component, kinetic object, to the method, and if kinetic object get as kinetic object is grounded, we want to be able to do this. And if the character is grounded, and this is where the setting is grounded but is not jumping, we want to make sure that our base velocity is 0. Okay, that works. Now we have to change our physics system to actually specify where something is grounded. So it's grounded when we have a collision in vertical direction going down. So it's here. So let's figure out where would be the good place to set the grounded one. So if we have a collision in the y direction, when going down, we'll be setting kinetic object set grounded true. Okay, this is going to be saved later on here after this method called, so we don't have to save it here. We just have to set it to true. Otherwise, if we're going down and there is no collision, we have to make sure that it's false. And if we're going up, whether we have collision or not, we have to set grounded to false. So if you're going up, you're not touching a ground, so you cannot move. The only point where you can move is when you were going down and you've hit the platform. When you are standing still, so there's no velocity, the nature of the grounded doesn't change. Okay, that works. Let's try it out if this is what we wanted to achieve. So I don't want to be able to double or triple or multiple jump, and I don't want to be able to move while being mid-air. So let's see if it works. Yeah, I can no longer move when I jump, and I can only jump once. Awesome. So we solved that problem, and we die. Okay, so let's maybe now modify the level a little bit and add a platform above our own to check that we hit it from the bottom as well. So we modify the level, introduce a platform above the starting platform, also made of grass. Okay, yeah, so we are hitting the head. When we jump, yeah, we fall. So our left side collision work as well. Now we'll check that our right side collision work. So we have to jump. Oh, I think I need some more space here. Let me move the platform on the left side one more to the left. By the way, this can be half a block. It doesn't have to be, or any other value. It doesn't have to be integers. We are operating on floats here. So let's go with floats then. Oh no, we have a problem. We are doing here parsed in instead of plus float. So I found a bug. I pressed the wrong button in IntelliJ. Okay, so it has to be float, not integers. So let's fix it very quickly and very easily. That should work now. Okay, so we now have a platform here that we can jump onto. We fall off it without jumps. However, if you want to jump on the other platform, it works. We should be able to fall as well. And if we jump like this, actually, I made the jump too far. Let's just start quickly. So there's something running in the background. No, it's not running. So let's jump here, and from the very edge, let's start to jump. Oh, and we hit the platform side, and we fell. So right, collision detection also works. So this is gonna be a short episode. Turns out the changes were really, really quick and really, really easy, as you can see. And from now on, the whole working on the game is going to be going downhill. The previous episode was very, very long because there was a lot of code and the code was rather complicated. I tried to do my best explaining what I'm doing, probably failed many, many times, but hopefully when you look at the code yourself, you'll finally figure out what's going on. If not, you can just ask me questions. I'll try to answer them. So that's it for this episode. If you like this series, like this video and other videos, and subscribe. Thanks for watching, and bye.